Hello, we're going to talk about CRI math when it's no longer a patient, just one patient that we're making this up for. We are going to make this up for multiple, or any patient is how you should look at it. More or less, you are creating a new concentration of the drug that can be run at a standard rate on any patient. And when this would be useful is for something like dopamine, when you have to have blood pressure support for multiple patients in a surgical day, and you want to be able to transfer the syringe or the bag of dopamine that you've made up and change the line in between patients and say, here you go, here's your standard concentration of dopamine that we always run at a ml per kg per hour, and every patient fits on it. And then you can titrate it up, down, sideways. That's what we're showing here. So your dopamine first, you need to know that it's 40 mg per mil concentration. That's what the bottle is. And we're going to change the concentration by taking just a little bit of that dopamine and diluting it out. So then you have to ask yourself, what rate, what concentration and rate are we talking about? Usually in your Plum, your Pay-Pitch, whatever formula you look it up, 5 mic per kg per hour is going to start to help with blood pressure support as an inotrope chronotrope dose. So at 5 mic per kg per hour, it's hard to use that because we're very used to mg per kg per hour. So we're going to convert 5 mic into mgs. You're actually going to divide 5 mic divided by 1,000. And that will get you your milligrams. So if we take 5 divided by 1,000, you get 0.005 milligrams. And that should make sense because a milligram is a very large volume or dose compared to 5 micrograms. It's a difference of 1,000 pieces, I suppose you could say. So when you have a large chunk of milligram and you're only talking about 5 micrograms of it, that makes sense why there's so many tiny zeros and a decimal point, because it's a tiny chunk of this milligram that is going to be making up 5 micrograms. So that's why the milligrams looks like it's ridiculously small, but that's how it converts. And then hours, how do you get to hour? This should say mg per kg per minute. That is usually what it says. But I have to convert my minutes into hours. And we know how to do that. Minutes is always a conversion factor of 60. 60 minutes in an hour. So that is going to get you 0.005 times 60 is 0.3 mg per kg per hour. So now we've made it. Mg per kg per hour. Now we take that 0.3, oh gosh, hang on. Have to have better handwriting. Now, if we want this for anyone and everyone, and it can be because this is a nice low dose. We're starting out at a nice low rate. We're starting out at, if we say want to put this into a syringe, then we're going to be thinking about, well, every say mil, every single mil needs to have 0.3 mg in each one of those mils, and then that will equal a ratio that makes sense. 0.3 in every single mil is going to look something like this. 0.3 mg per kg per hour is going to be the same ratio as 1 mil per kg per hour. That's how it looks when it's written out, when you're thinking about this kind of stuff and putting the dopamine per 1 mil at this low dose. And how that translates for you is that any patient, whatever their kilogram dose is, he's 4.6 kilograms. I'm going to run this at a mil per kg per hour on my 4.6 kilogram patient. So that dose is now 4.6 mil per hour. There you go. Let's say he weighs 32 kgs. That's going to translate into 32 mil per hour. Because 1 mil times your kg gets you how many mils per hour you need to be running this at. And you know, again, each one of those mils is going to have 0.3 mg per kg per hour in it. And that's the exact dose we were already looking for. So easy. Well, thank you, S Pen. I did need to hear that. The same thing works for a bag of saline. That's going to have our line set up with it. Let's say we picked a 250 bag of saline, 250 mil bag of saline, and then we break up this entire bag of saline into 1 mil pieces, and each 1 mil of the 250 has 0.3 mg of dopamine in each and every one of these mils. Well, an easier way to do that would be 0.3 times 250. So now I've got 75 mg I need to add into that entire 250 bag. 75 mg doesn't mean anything, right? We still need mil. So 75 divided by the concentration, which is 40, gets you 1.875. And because I round up to 1.9 mil. 1.9 mil added to 250 mil saline. And I keep saying saline because dopamine, dobutamine, norepinephrine, they all play very well with saline, but they don't necessarily play well with other drugs like LRS or Normasol or any of those other ones. It's just safer to fill it in with saline. So if you're going to do it this way, please have some saline on hand so that you can do it. Now, if you're going to do this syringe idea, you can fill each one of the mils of your syringe with 0.3 mg of dopamine, and you will then therefore have 0.3 mg per hour in each one of those mils. All right? And if you're going to pick, let's say, the largest syringe that we have, a 60 mil syringe. Oh my gosh. Syringe. There you go. Spelling. A 60 mil syringe. So you're going to take that times 0.3 mg in each one of those mils. In each one. So 60 times 0.3. Now I have 18 mg. Again, mg is useless, so we take it divided by the 40, which is our concentration. And now we have 0.45 cc's that we would add into a 60 mil syringe. Now, if you remember from a video or so ago, there's a concept of QS, quantity sufficient. If I said I was going to only work with 60 mils total, I cannot fill up my syringe with 60 mil and then add my 0.45 cc's, because now I'm 60.45 cc's, and that's not how I did the math. The concentration is now incorrect. So I'm going to take that 60 cc syringe, and I'm going to only fill it up maybe with 10 mils, right? Just so I can have enough saline so that I can mix these two together, syringe from syringe. We've all done it. We've all seen it. So within that 10 mils, I'm adding my 0.45 cc's, And whatever volume that creates, I just keep filling that syringe now, a little bit more from my bottle or bag of saline, until I get to the 60 cc mark. And then I stop at the 60 cc mark. And now I know I have 60 mils total. And that's all I wanted. And again, each one of those mils has 0.3 mg in a mil. So if I'm running each of those mgs, or excuse me, each one of those mils times the kgs, I'm going to get 0.3 mg per kg. And that was my original dose, 0.3 mg per kg. And I run it every hour at whatever the rate says so. Again, I am a 14.2 kg chubby pug, and I'm going to run my syringe at 14.2 mil per hour of dopamine. And then I will be at 0.3 mg per kg per hour, which is the same as 5 mic per kg per minute. And then I can titrate that up, down, wherever I need to maintain my blood pressure.